Okay, so this is going to be a video going through some of the features of Scene, such as georeferencing a point cloud, creating a heat map on concrete, locating and getting some coordinates of rebar, and then running a Ffl test on the concrete. So I'll start off with georeferencing, and what we have here on the screen already is a already registered point cloud of a street made up of what you can see on the left here is just 3 scans. And there are about a dozen targets, and 3 of them have been surveyed with survey control points so that they can be put on the project coordinate system. The very first step is to create a new cluster which to place the current point cloud in. What do we got here? Close that. Create a new cluster, call it GeoRef. Place all the scans within it. And now drag in our CSV file of our 3 survey target points in the point, eastern, northern, and then Z direction is the format. So I'll minimize that and then drag and drop. Import. Okay. So then all that's left now is to run a targeted registration. But first, actually, let me show you, prove to you that this is just floating in space. Let me pull up the first target here. So we've got a coordinate of about 59, 321, and -12 is the coordinate for the target in this current system. And then after running this targeted registration, you'll see that it has moved. After I deselect auto clustering, our results are right here. So our first target is off by 2 millimeters, 2.5 millimeters, and 1.8. So that's great. Our error is around, well, less than 1/8 of an inch. And now let me pull up, reload the screen. And now if I double click on this point, it's changed now to, 4,500, 2,500, and 11 is now the coordinate. And you can actually zoom in here and see that we've got our coordinate right on the target. Another right on the target, and number 3, survey control point, spot on. Wait, where's a better view? Okay, yeah, there's our target. So that's how easy it is to just drag and drop the CSV file into Scene, run a targeted registration, and snap to project coordinate system. So let me close out of this project and get into some of the construction site features. So this can be done with a single scan workflow, and the great thing about a single scan workflow is there's no registration. All I've done beforehand is create a clipping box here, and with the single scan workflow everything can be done very quickly and efficiently. So I'm just working from a top-down view right now, and I guess I'll get started on the rebar. Now what I would do is, if I needed to know the location of rebar, I would, just as in my previous example, register to a project coordinate system, georeferencing this point cloud. Then I would jump into the old user interface so I can use this mark scan point feature, and then you can just click along the line of rebar here, creating points, identifying intersections in the rebar, and then I can kind of rotate around and make sure that I'm happy with my picks. Yeah, looks like I got 2 levels there, going low and up high, but again, identifying the rebar, and then you can come over to these matched objects and check the coordinates of each one of those chosen spots, helping you to identify the rebar after concrete's been poured on top of it. Let's see what's next here. Let's create a heat map. So again, starting from a top-down view, just want to get a little closer. Switch over to the new interface and open up the Rhythm apps, specifically Builder. So to make a heat map, it's as simple as clicking on the surface icon and then heat map. A little tutorial comes up telling you to select your corners. Thanks for the reminder. And just by picking corner 1, corner 2, corner 3, and 4, hit enter to close, and then you get a few options. You can have absolute elevation with the average elevation being green, or you can go relative and it'll give you the actual elevation of the surface. The number of intervals you can choose from average up to your maximum and minimum, and by hitting apply, it'll then create the heat map. So what we've got here is it's telling me that the red spots are higher than 3/8 of a feet, which is 3/8 of a inch, and blue spots are about 1/4 of an inch low. And I think these red streaks are actually rebar, which is poking up through the surface. And again, if you wanted to see this in absolute elevation, (97 feet), and then the corresponding higher and low spots. So that's how it's quick and easy to make heat maps. Close this out and clean the point cloud. And then I'll show you how to run a quick little slab monitoring. So if you had a freshly laid deck, and you could take elevations of that deck, and then after some time has passed, check the elevation against its original height. So to do so, first we want to lay out a grid of points. The good descriptor is usually the day that the concrete has been poured or the day that you've scanned. Today's date is 11/18/2016. I'd like to start with number 1, and a grid spacing of 2 feet is what I like, but you can choose whatever interval your little heart desires. So I'll hit continue, follow the little direction that comes up here, and identify corners of the grid. 1, 2, 3. And am I satisfied with the points? Yes, I am. It finalizes them and creates a little report with blue being low spots, red high, and green right in the average. I'll zoom in a little closer. I guess blue is hard to see, but green shows up nice. It's the point number and elevation, and the color gives you a little bit of relative nature of the elevation. So we've created a grid of points from the original pour day. What we want to do now is export it and save it for later. So choose export, CSV file. I'll browse and put it on my desktop, and I'll name it concrete pour from today's date. Save it and export. Export successful. Wonderful. So it just gives you a little preview here. You can open it up, and just a CSV file. On the left, this is the street survey CSV file. But there's our exported grid of points and elevations, which we will import now after simulating deck settling. So to simulate the deck settling, I can pull a little trick here and go to scans, properties, transformation. In a previous demo, I dropped it down a foot, so currently it's at -1 feet, but I'm going to drop it 1 more foot lower in elevation, so -2, apply, OK. Let me open Builder up again, get a fresh, clean start. So what I have simulated now is a scan in the future. So we've scanned in the future, we've registered this to the project coordinate system, and I've settled it by that little trick there. I've made it drop 1 foot lower than the grid of points that I had created just a moment ago, and this is to simulate the settling that can happen over time. But now we've got an old CSV file and a new point cloud. We want to run an analysis of a monitor in the changes. And that involves importing that CSV file. So we want to import ground monitoring and then find it on our desktop here. Concrete pour, open, and import. And what we should see here is it'll tell us that the deck has dropped 1 foot in every one of these positions. So I can see here at date 11/18/2016, 0.47, -1 foot. And that is the same for every one of these points. I guess another final trick is running an Ffl test yourself. So again, I'm going to clean up point cloud here, open up another one of the rhythm apps, Inspector app, and simply click on the floor flatness icon. Now the wonderful thing about this little tool is it follows exactly the ASTM 1155 standard, so you're not you're not faking this Ffl test. This is a real test that can be certified. So you just follow the directions here. Please start by creating a line and identifying 2 points. Make a nice little grid right here. 2 more points. Work in the other direction. Then hit enter, run the analysis, and a report pops up. Let's see here. We want to. So this is just the little temporary report inside of the app, inside of the scene, excuse me. But if we want to create the report as an exported file, there we go. Here's our PDF with a nice little screenshot, title, and all the data of our passing for our FF and FL test. Get the FF numbers, confidence, and the criteria for pass-fail can be changed within the settings of the rhythm app. So these are a few of the features that can be used within Scene on construction sites. And should you have any more questions, please feel free to give me a call or send me an email. Thank you very much and have a great day.